Inventory forecast, statistical test with Excel to see if your data is helpful in predicting seasonal demand. We are going to apply the Durbin-Watson test to see if the data has autocorrelation to the past and has influence on the present to do predictions. This is a topic of this book of data forecasting and segmentation using Microsoft Excel. Perform data grouping, linear prediction, and time series machine learning statistics without using code. And the link to buy this book in Amazon, it is on this post. So we are going to see this topic. First, the forecast to predict the seasonal demand of the inventory. The machine learning uses the 80% of the data sample to train the model and the rest of the 20% to test the prediction. Before using the training data, we must check if the values are useful to do forecasts. The values need autocorrelation, meaning that the past behavior influences the present values. For this matter, we are going to use the Dublin-Watson statistical test to measure the autocorrelation level and see if the data is useful to input to the machine learning forecast model. For example, we will see these two cases. First, the air ticket sales from 5 years. The source it is the air passengers in Kaggle in the figure 1. And the second it is the seasonal sales for Canada from Canada. The source it is the global superstore ML in Kaggle in figure 2. So this is the air ticket sales. We can see that the sales it is on the gray line here. Okay, we have the regression line which is on yellow. This is, and the prediction line it is on blue. Okay, so we can see that the sales that are in gray, we can see that it has a seasonal behavior, meaning that probably this data is useful to make predictions for the seasonal demand on the future. Okay, so we can see the trending here, and what we are going to use in the Dublin-Watson test is the separation between the data of the sales, this seasonal demand, from the regression line, which is known as the error linear regression. Okay, so the air ticket sales have a seasonal trending, having up and downs over the months and years. We can see that the trending it is that after 3, 4, and 5 years, we can see that the trending is that the sales are going up. Okay, so we can see this trending. Remember, it is the gray line. On the contrary, we have the Canadian profits from these data sets, and we can see that this is the regression line in blue here. We can see that it doesn't have a regular behavior. We can see that after several months of data, this is not a regular behavior, so probably this data is not useful to make forecasts. Okay, so even if you have a large amount of data, that doesn't mean that it will be useful to make a forecast of the demand of this product. Okay, so that's why we have to make this Dublin test before. Okay, we have the Durbin-Watson test. The Durbin-Watson test uses the linear regression errors to see the autocorrelation of the data. We means by autocorrelation that it has an influence, the data has an influence on the present from the past. Okay, that means that it could be useful to make predictions or forecasts for the future. Okay, so the errors are the difference in distance between the seasonal up and down movement from the regression line, like in figure 3. Like we explained before, we have the sales. The sales it is on the blue line here. The regression line it is on the orange. Okay, so orange it is the regression line, and the blue line it is the seasonal demand of the air tickets, and the separation between the sale and the regression line, that's what we know as the error for the linear model. Okay, So the seasonal sales of air tickets and distance between sales and regression line, this distance, we plot this distance on this chart, on the residuals, okay? So these are the residuals of the linear regression, and here we are going to make the measures using the Durbin-Watson. We can see that it has a regular behavior, so these errors, this difference of residuals have a seasonal behavior, meaning that probably the data is useful to build a prediction or forecast. Okay, so the Durbin-Watson test, from the errors chart we can review the training periodic behavior of the data. The Durbin-Watson test has the following range of values. From these values we can conclude if the data is useful to do prediction. The value of the Durbin-Watson test is 2, so that means that there is no correlation. Okay, so this value of 2 means that there is no autocorrelation, so the data is not useful to build a prediction model. If the value is between 0 and 2, it has a positive autocorrelation. The positive autocorrelation, it means that it is growing through time. Okay, it has a growing trending through the years, and if the value it is between 2 and 4, it has a negative autocorrelation. So that means that the data is going down. So this is the formula for the Durbin-Watson, okay, where we get that the ET, it is the actual error term, and the ET minus 1, it is the prior error term to ET, okay. The numerator, it is the sum from the term number 2 to n square, okay. So this is the formula for the Durbin-Watson, and we apply this formula to these residuals, okay. These residuals, we apply this formula, and the denominator is the sum from the term number 1 to the n square, okay. Okay, so these these are the residuals or the errors of the linear regression. It are each term of this chart, okay. So we are going to apply this formula to each term of this chart to get the results from the Durbin-Watson formula. Once we have the results, we divided the numerator and the denominator, and the result is 0.75. So since the value is between 0 and 2, that means that the data has a positive autocorrelation like we predict before. Okay, so this data is useful to make prediction. The values are growing through time, and this is the forecast result that we get from the model. And this is the confirmation of figure 1 because it has an increasing seasonal autocorrelation. So the data is useful to the forecast. On the contrary, we apply the Durbin-Watson to the Canadian sales, and it has a value of 2.4. So that means that the data, it doesn't have autocorrelation, confirming the fact in figure 2, where we see that no changes are per month and years of data. So here it is the regression line, and we can see that there are no seasonal trending of the data. So this data is not useful to build a forecast. Okay, so all these topics you can find on this book, and you can buy this book on the link that appears on this post.